Welcome back to the hyperbolic suffering chamber. We are back once again. We are here. I don't think I've read the comments the last few days because I have been short on time, but we're still short on time, but we'll still read them today. So that's what we're gonna get into. Been doing 30-minute sessions. It actually seems like the last couple of problems we've tried have been actually slightly difficult, so that's probably a good thing. Keep the difficulty raising. But yeah, I'm still excited to get to the mediums. I was looking at the roadmap, and it looks like we are at around 322 completed, and we're at 273. So I think almost halfway through the easies. So from there, hopefully we can keep going. It looks like we're still half right. Looks like LeetCode adds about one problem per day. So I think as long as we keep, or it's like 0.8 problems a day or something like that. But I think as long as we solve one or two, we should be fine. It should all average out in the end. So fortunately, I think even the problems we do later on, like earlier in the week, add to this. So even if we don't solve a problem every day, I think we're still making progress somehow. So a little day goes a long way. That being said, we have some comments, I think, to take a look at. We have a comment from Jeremiah Benjamin 4 hours ago, the God King himself. He says, "Stay on the grind, my friend. I am on it too. We are going to make it. Only one of us is going to make it, and it's going to be you." Feels strong, man. True. The grind cannot stop. I was actually a lot of cool people in Discord talking about the grind, staying on the grind, sharing a lot of resources, as well as tips and cheat codes. So, yeah, I think, this is pretty cool. So, hopefully, we can stay focused. There are a lot of things vying for our attention. So, I think we've been able to modulate the time when attention is struggling. So, we're just making sure we try and do something every day. And that seems to be working for now. I don't think we could have made this week work if I was doing an hour every day or more. So 30 minutes seems to be the sweet spot. So yeah, we just got to stay focused and do what we can. Show up every day. Feels strong, man. I'll see you at the top, Sensei. Yeah, so we are going to make it. I also did a couple silent sessions because I didn't feel like talking. So I think it has to be like that sometimes. I think in the past I probably wouldn't have uploaded the video, but I can't hope for perfection if I'm going to do it every day. So I've uploaded it anyway, even though it was hard to do it, but I'm glad I did. So maybe more silent sessions. If things get hard in some way, we're just going to dial it back to make it make sense. So just like when we used to do like 3 hours, when it got difficult, we just dialed back the hours. And then when we did less time and we were doing mediums and hards every day, I was like, okay, we just have to go through the mediums. I mean, through the easy. So we have a lot of time, so we don't actually have to, like, we're not dying to get any specific number of problems done. So we definitely have the privilege to take our time, which is pretty good. But if you don't have privilege of time, there's definitely much better guides and people on the internet who've already calculated the most efficient way to prep for LeetCode and the most optimal problem dissection, or subsection. So that is pretty much where we're at. And then we have a comment from Akil. "I heard Elon flew you out and you embarrassed yourself on his private plane." This is half true. This is half true. So the real story is actually in the Discord. So after that plane flight, we actually hopped in the VC. We just hopped on in the VC afterwards in Discord. So all the people in the Discord were there. We were just chumming it up. So if you're interested in something like that, you should definitely join the Discord. Because, yeah, I mean, Elon was dapping up everyone in the Discord. I mean, you can't really beat that. So this is actually true. So that being the case, the reason we were on this plane is because we were actually headed to the Gigafactory unveiling, the press conference that just went live today. So if you look at a particular frame, you might see a couple of the top HCC members as well as the executive board there. But yeah, the real ones will know, and I think that's kind of where we are at. That being the case, I think we're going to do a standard 30-minute session. I think we'll be back to the regular hour next week, and then we can continue blazing through. But little day, so that being the case, I think we were doing a matrix problem. and we were being schemed by the LeetCode developers. So I think they unblocked my account because I'm pretty sure my solution was a little too fast. So I think we should be able to fix this one today. I was trying to rush to fix it, and I failed. So basically, we have to check if a matrix, given a matrix, right, we have to ensure that the diagonals always have non-zero numbers and the non-diagonals have zeros in them. That being the case, you can check for diagonals going from left to right if the rows and the column are the same, but that doesn't actually line up for checking top right to bottom left. So to swap that around, we just have to swap the column order when we do our checks. And so we'll have something called call len, which would just be able, not even just call len, but it's just the last index in column, but we'll just call it that anyway. And we'll just say it's going to be grid.length -1. It's a square matrix, so it actually doesn't really matter which one we use. And we'll keep the row the same, but when we subscript the second indice with the call length, we use call itself. That way, when we're actually at index 0 for the column, we can actually check for the last index in the row, which would be the length of the grid, which is 4 minus 1, which is 3, minus 0, which would give us 3. So I think if we hit run now, it should work. Oh, I think we have to remove the other code we wrote, actually. So let me do that really fast. And we'll delete row len. Okay, we're still wrong, so. Maybe it has to do with the order and checking. Oh, we have a minus sign here. So call length minus call equals 0. So I think we can remove this case down here. And then we can combine the cases appear to check at the same time. And we can do grid sub row sub call length minus call equals 0, then we should return false. I should check for the diagonals, both diagonals going top left to bottom right and top right to bottom left. But then from here, call does not equal row. There's a way that making sure the column and the row are the same gives us a diagonal, but it's also the same where column and row aren't the same. Gives us an issue where we have to check the other, or we have to exclude the other diagonal. But we could also say and all does not equal colon. Well, 3 does not equal 3. Feels like this should be working. It's interesting. 1 does not equal 3. 3 does. Let me do call and call in. Oh. One, two. It should definitely be that it's 0. Right, if it's... Oh no, that would make it part of a diagonal. I think we should just abstract this all out up here. And then we'll return a Boolean. Then we can simplify everything out here to then we'll return false. Else if it's not diagonal, and grids of rows of call does not equal 0, will return false. Now we can simplify this to just if something is diagonal or not. It's diagonal if the column equals the row, right? So 1, 1, right? But at the same time, the opposite must also be true. Right? 0, 0 is a column here, but 0, 4 is also a diagonal. So I feel like since the rows are staying the same, we just need to modulate how we deal with the columns. What if we say if the row is equal to if the length minus the row, no, if the length minus the column is equal to the row, it's also diagonal. Oops. I meant or. So call equals row gives us true here. And then what about this one? This would be 0, 1. Columns are the same. What about len, which is 4? 4 minus call. Four minus 1 gives you 3. 4 minus 2 gives you 2, and then 4 minus 3 gives you 1. We should pass in minus 1. I see. Okay, so it looks like what we should have did was just abstract this out to a function, because then we started getting lost in the sauce, making this much harder than it needed to be. So length of the column, right, of the total length of the max length of the column minus the current column is equal to the row. So length, which is 0, 1, 2, 3, or the last element of the row. So 4 or 3 minus the last column, which is 3, is what you go to the row, which would make it so that this would actually be seen as a diagonal. Row I in column J, if the row is equal to the length of the matrix minus 1 minus the actual column. So it's the same thing we just did, basically. So we have range addition. You are given an m-bind matrix, M initialized with all zeros, and an array of operations ops. Ops sub I is equal to A sub I. B sub I means M sub xy should be incremented by 1 for all. So all the values between 0 to be incremented by 1. So it's basically showing us that we're given M is equal to 3, N is equal to 3. We have ops 2 and 2, which means starting from 0 going all the way up to and including X. And then starting up from 0 and going all the way up to including Y, we should add 1. If that's the case, we'd add 1 to here. So we do, 0 is less than or equal to X, but it should be exclusive of the N. So we should 0, 1, add 1 to index 0, 1, right? And 1, 1 here as well. And then we should kind of return the number of maximum integers in the matrix. The number of maximum integers. I see, so we have to set it up and then loop through it and check the max. So we could perform ops plus keep track of max. Again, and count maxes. So we could do for xy of ops, right, for row equals 0, row is less than x, row plus plus, Oh, we already have to have the matrix. So we'll let this equal to negative infinity. On each iteration, we'll say max num is equal to math dot max of max num and mat sub row sub all. And then we'll do the same thing again and count. Say if mat sub row sub call equals max num, we'll do ct plus equal 1. And then that's a good edge case. Wait. Oh, the number of them. So you would just return m times n. Oh, so we have a massive number. Guess we should have checked this. Yeah, we should have checked this. So I think there's another way we can do this with overlapping instead. So I think we'll try that tomorrow.